Ladies and gentlemen, welcome to the digital ground segment. Why, how, and what will it take? So to introduce myself, Simon Swift, I'm Engineering Director for ETL Systems. ETL Systems is an RF company that does basically everything that sits between the antenna and the modem. I'm also the chair of the Diffie Specification Working Group. So I've been doing a lot of work with Stuart and with other guys on Diffie to introduce and bring standardization into digitalization of the ground segment. I sit on the board of Diffie as well. And you'll see we've got an absolutely fantastic panel here today of all sectors relating to ground segment digitalization. So I'll introduce each of them briefly. We'll then have our panel discussion. And then we'll keep 10 minutes at the end of the session for questions. So starting off, we have here Stuart Daughtridge, SVP of Advanced Technologies for Kratos. We have Michel Dothey, Chief Commercial Officer for neXat, who have just taken the WTA Teleport Technology of the Year Award, which Michel is very, very proudly wielding here. We have Elizov, who is Vice President for Products in Marketing and Defense. And finally, we have Ethan Lin, Vice President and co-founder of TMYTEK. So, if you'd all like to starting with Stuart, please fill in the gaps. Tell people about where you fit into this digitalization picture.
Okay, so first off, Kratos is a company that does satellite ground systems. We do everything from the antennas all the way back through the signal processing. And with digital ground systems, we've been working for several years now about focusing on virtualizing the ground system. So taking what used to be done in purpose-built hardware and virtualize it into containerized software applications to virtualize the functions and allow for more dynamic satellite ground systems.
Thank you. Concerning neXat, in fact, we are not in the VSAT side. We are not on the satellite.
Uh-oh. I think you're thinking...
There's always a last minute. Michel, in the meantime, why don't you carry... Gil, in the meantime, why don't you carry on and...
No problem. So Gilat, as you probably know, is a leading modems and baseband provider for many years. And by doing that, I think I will start by addressing the why as part of the introduction, because I don't think there is a question of why. As a producer and provider of satellite ground segment solutions, we know that digital ground segment is the next step. It's probably the current step in many places, and we will talk a lot about it later on, but it's part of what we believe in Gilat. We will talk probably on Diffie and Wave and all those stuff, and this is exactly where we see the current and the future of the satellite industry, the ground segment part of the satellite industry.
Okay, and back to Michel now.
It's working now? Okay, perfect. Then, in order to provide SATCOM, you need different pieces in the puzzle. You need the VSAT. This is not for us. You need the satellite. This is not for us. You need the hub. This is not for us. But you need also an OSS-BSS in order to have all those pieces working together. And this is what we are providing. Then it's a complete OSS, it's virtualized, it's in the cloud, and it's compatible with different technologies. And now we are also going to the standard, but this is something we will discuss later. Thank you.
And Ethan.
Hey, thank you. My name is Ethan from TMYTEK. We're a Taiwan-based company. We focus on millimeter wave technology. We build up electronic steering array antenna for satcom. So essentially, ESA antenna is not only a pure analog devices. It's been part of a digital process there. So we definitely are part of this digitalization discussion. So thank you for having me today.
Okay, so our first question to think about is, what do you see as the real driving market imperative for digitalization? And how do you see the funding coming to that, and how do you see that cost model developing? And Stuart, why don't you kick that one off?
Okay, so I see there's two things that are going to drive the need for digital ground systems. One is the VHTS satellites and the software-defined satellites. You know, they have massively more capacity, and it's very flexible capacity in orbit. And the only way you're going to get your value out of that capacity is with a highly dynamic ground system. Because if you can update your satellites on a regular basis, reconfiguring it to the needs of your demand, you need your ground system to be able to coordinate and be just as flexible. And that happens by digitizing the ground and virtualizing it so that you can orchestrate the services on the ground in a way to optimize your bandwidth utilization. The second thing that will drive this is cost. You know, as we all know, Starlink is changing the industry with their pricing models. And, you know, if you're anyone else in the industry, you have to figure out how you're going to respond and get your costs down. Part of that is by going to the HTS satellites and the software-defined satellites to reduce your cost per bit through your space segment. But you need to do the same thing through your ground segment. And digitizing the ground, moving it to virtualized applications so that now that you could have a software-defined ground where you could buy it as your ground as a service, tying your ground system acquisitions to your revenue versus having to buy all the hardware for your ground system up front. All these things will help reduce costs. The other thing it will do is enable the use of 5G across satellite. And with 5G NTN, that allows you to plug into a larger ecosystem, the 5G ecosystem. And by doing that, again, it's another way to help drive down your ground system costs. So I think those are some of the big industry drivers that will push people to digital ground.
And how do you see the funding model for that developing, though?
I think what's going to happen is as they bring on new capacity for new satellites get launched, as part of the CapEx and the development of that ground system for those systems, that's where the funding will come from. I doubt you'll ever see them change out and remove what they already have on their legacy satellites because the switching cost is just way too high. But on new capacity, as they bring in new capabilities, that's where you'll see digital ground get, and that's where the funding will come from.
Oh. Michael, please.
Yeah, thank you. Of course, I agree completely with Stuart. That's totally true. And of course, it's mainly operational cost that is a driving factor. Because nowadays we have to really automate and to orchestrate everything in order to have this gain in terms of operational cost and also interoperability between the different networks. This is also extremely important nowadays. Flexibility, this is also something that is more and more important. And in terms of market, I think that the first very important market for that is probably governmental markets that needs really all those features. And this is,
So do you think this will be a government-driven?
In the beginning, yes, for sure. And after that, of course, you will have the adoption in the other markets. But I think the driver, because this was the question, is probably the governmental market.
Gil, this fits very much in with your job title, doesn't it? So please, I'm sure you've got some good comments on this.
So I will try to do it without repeating what my colleague said here, but to add another layer to that is we are living in an area that the satellite industry is evolving very fast. Technology-wise, capacity, services, multi-orbit, multi-bands, all of this is coming and it changes a lot in our industry. Digital transformation of the ground segment is crucial for that. Add to that the fact that satellite industry is maybe the last industry to move into digitalization, the last industry to move into cloud and to move to those areas that all the other communication industry already did. I'm sure Ethan will talk about 5G as well, 5G NTN, 6G, all of that at the end is driving a digital transformation that needs to happen first of all on the gateway side, but let's not ignore at the end it will come also to the modem, to the remote side. And this is the technical changes that also drive part of this commercial change, operational change, and everything that goes around that.
So do you think also it's going to be a military government thing pushed first and then with the rest of industry being drawn along? Or?
Typically, in those kind of changes, it starts from where the money comes, government, defense, those kind of things, and then the commercial catch up with that. So yes, of course, we are starting to see, I think for the last 10 years, we are hearing about the need to move to digital, to do all kind of things. I think Kratos did some excellent things in the last few years around this area. There is a lot of standardization that goes around that. We will talk about it later on for sure. And yes, start from government and then goes to commercial and other stuff.
And how about you, Ethan?
Yes, from my point of view, I think I will look in the very fundamental level. First, why we need digitalization. First, it's about scalability. So from what we learned from 5G, because we are moving from 5G and transforming to satellite world. For example, now multi-orbit it's driving by resilience network, and that's required by military, for example. So that's the main driving force. And what matters in this is about scalability. So from ESA point of view, how to build scalable antenna instead of just a piece of hardware. Or whenever we need to connect to LEO, we need another antenna. We connect to GEO, we need another antenna. Now we have a universal antenna, and reconfigure that through software. So software defined can definitely help the scalability. And I think the second is about, of course, it is associated to the cost. Right? So whenever we invest the hardware one time, and we configure through software to fulfill different demand, that's definitely one of the reasons we can save the cost.
And how do you see? Sorry,
Can I add one more thing to that?
go for it.
It's worth noting that we all gave answers related to satellite, related to satcom. But if you look at like the Earth observation market, those ground systems have already transitioned to digital. If you look at KSAT, RBC, Atlas, any of the ground as a service companies, they have already gone to a software-defined ground where they digitize and all of their modems are done in software, where they virtualize the ground system. So it's not, and they moved that way about 5-6 years ago because they had to. It was the only way to get their cost points down. If your satellite's only going to cost you $500,000 to $1 million CubeSat, you can't have a $3 million ground system. And so they had to find ways to more cost effectively get their, to get their ground system cost. And so they went to digital ground. And so it's already happened there. It's now just moving into the SATCOM market.
That's actually a really, really nice segue into the next sort of thought, is that we're going to have to think a lot more about different infrastructure. I think the skill set is changing and customer understanding needs to change with it. For example, suddenly we're needing to think about things like bit depths, how that changes to dynamic ranges, how that then translates across network bandwidth requirements. So guys, what are your thoughts on the emerging skill sets that are going to be needed and how the industry will adapt to those skill sets?
So you want me to go first?
Go. Yep.
So we support the Earth observation market and with digital ground solution today. And what we've found is that the transition there's absolutely a transition. There's absolutely a transition of skill sets. But, it's not magic, it's math. And, the customers are smart and they pick up on it very quickly. They realize that, their IT network now matters a lot more than it used to when it's carrying RF data that's got to be, delivered in real time. But I don't think the technical challenges are really anywhere near as hard as the challenges in analog. And since the industry solved analog, I'm sure we can solve digital.
Of course, there's always going to be analog somewhere in the chain.
Well, that's true.
Please, Michael.
Yeah, concerning skills, I think that there is nothing really new, in fact, especially concerning OSS, BSS. In fact, this part of the system, this is something that, in fact, due to the fact that we are orchestrating, automating a lot of things, then, in fact, we help to reduce the cost of the manpower in the teleport, and we push the maximum to the hand of the customers. And with the tools we are providing through the portals, they can manage themselves a lot of things, and are very pleased to do that because they can directly push their needs, the user requirement, and everything is done for them, and it's totally automatized. Then, in terms of skills, I don't think that it requires more skills than before.
But it's quite a different skill set. Do you think that's a positive influence from the available labour pool, or negative? Where do you see that balance coming?
I think that, people will adapt, and the industry will adapt. But in my point of view, it's not a very, very big challenge. This is something we are helping. Of course, we are giving trainings, for sure. And after that, it's something that they can learn very, very quickly. We had the experience now, typical example with Arabsat. We deploy our system in 4 months. We interconnect 6 hubs from them, and they had to learn because they were up to now just selling megahertz. And now, they decide strategically to sell managed services. They didn't know anything about managed services. But then we teach them, and in 4 months, we interconnecting and we teach them, and now they are totally autonomous. That's the way it works. Then it doesn't require two very high-skilled people. That's something that is, for our part, that is not required.
I think one of the observations I would make of people coming from, graduates coming from university, you have far fewer people who are capable of doing RF than you have who are capable of doing IT. So from my point of view, I see it as a positive benefit. But Gil, what's your experience?
I agree with my colleague when it comes to OSS, BSS. But if you look on the transformation of digitalization from modems and baseband point of view, there is a shift of technology and skills. It shifts from vendor equipment like ourselves, like Gilat, to the operator, the satellite operator and the hub operator. Companies like Gilat and iDirect and others are doing now the shift from being in hardware-based companies to be a software-based company. It's a change in skill on the vendors.
Yeah.
The satellite operator itself now takes the responsibility on the hardware. They now need to manage the cloud. If it's a private cloud, if it's a public cloud, it's still a cloud that you need to manage. The infrastructure to it, the security around that. So there is a shift of skills between the companies. Things that typically vendor of equipment were doing, providing a full solution with the switches, with the servers, with everything. Now they bring only software. When you bring software, it's a different skill. But someone needs to bring the hardware. Now it's the satellite operators, the hub operators. It's their responsibility to bring the hardware. They need a new set of skills. So there is a shift of skills between the companies, between what the vendors are bringing, what the operators are bringing.
Yeah,
and do you think your customers are adapting well to those changes?
Some of them are adapting better and faster. Some of them are doing it a little bit slow, like the vendor itself. Some vendors are moving faster into the software area. Some are moving a little bit slow. But at the end of the road, year, 2 years, 3 years, everyone will take the number they want. Everybody will need to be there because there is no way that you can support all the technology changes, all the demand of the market, the competition, which is being much more brutal than in the past. You cannot deal with that without doing those changes. It's crucial for the business. So it needs to happen. Some will do it faster, some will do it slower, but at the end, everybody will do this transformation.
Yeah. Ethan, what's your take on this?
Yeah, we do see the skill gap. Let me give an example. So we try to mitigate the gap. How? For example, for traditional analog antenna, you don't need a software API, that kind of stuff, or SDK, that kind of thing. And now we are doing ESA, right? So we have, for us, first we build up the SDK and the software documentation API. So that's number one thing. And second thing that it comes to my mind is that I just came from Barcelona, MWC, Mobile World Congress. So literally, we are my company is cross 5G and satcom, so that I fly over. What I learned from there is that digital twin can help. Digital twin can create the reality in digital world. So that can help to mitigate, to educate a newcomer to see what's going on here or there, because we are already built a good model and put that model in digital world. So that basically there's two things from my opinion.
Thank you. So digitalization, that involves the translation of a lot of analog components into the digital domain, things that are traditionally the RF. But that's only part of the system. There has to be many, many pieces of this different puzzle that have to come together. So I'd like to ask the question of how well do you think, how well served is that complete picture in a true competitive landscape for the end users? And let's start that off with Michael.
Yeah, thank you. Yeah, indeed, you're right. Different pieces, and each pieces are moving at their own speed. And typically, OSS, BSS, we were already there, also in the analog world, I must say, because we are, in fact, orchestrating everything, orchestrating the hubs via API. And now, okay, for us, if it's a physical hub or if it's a virtual hub, for us, it doesn't change anything. It's exactly the same. Then the changes are mainly for the terminal, at the VSAT, for the antennas, and also, of course, at the hub level, because now they are moving to be virtualized, they are moving in the cloud, and the changes are mainly at that level.
So the changes are comparatively little for you, but what's your impression of the overall availability in the industry of a full digitalized ground solution?
But it's growing. We see the evolution, and really we see that now most of hub manufacturers are going to full digital implementation. That's clearly the trend, and I think it makes a lot of sense because also the power of the CPU, etc., are increasing dramatically, and things that were totally impossible a few years ago are now totally feasible and more affordable. Because in the beginning, of course, the cost of the power of the processing cost was very high. But now we see that the price are going down, and it's more and more affordable and make a lot more and more sense to go in that direction. That's exactly what we see now.
Okay, thank you. Ethan, perhaps you'd come in on that because you're very much more focused on the antenna side of it and the 5G side of it. So you're, if you like, at almost some of the extremes.
So definitely now the network, especially heterogeneous network, makes everything very complicated. So that's also one of the reasons we need digitalization. Like I just mentioned about a 5G non-terrestrial network. So actually we need to take care of 5G part, satcom part, right? So digitalization is definitely one of the solution to address this complexity. So from my point of view is that first a better integration between different components. So make antenna as an example. So now how do we fulfill multi-orbit? How do we? What levels of API we have to provide to a modem designer and a modem a company? So that's a question about integration, right? So to fulfill that, I think first different components, different company. I would define it's more like a partnership landscape instead of competitive landscape. We need to build a partnership. For example, how do we build an antenna? It's universal for all the modem providers, right? That's my dream. But unfortunately, so far, it's still very device specific. So I think we lack of some standardization. We need to define the standards.
So at that point, I'm just going to do a shameless plug for some of the work Diffie's doing on the electronically steerable antenna and encourage anyone in the ESA arena to come and contribute to that to that working group. So sorry to interrupt you there, but please carry on.
No. So I think that's my opinion.
Okay.
I want to take something on that. I think the holy grail of that change is interoperability. We didn't mention that word yet, but I think this is the main challenge and this is the main change. The idea is that you are not going to be bound to one solution. Like Ethan said, you take the something happened. Sorry. You take the ESA antenna, and now you need to integrate it with different kind of modem digitizers, equipment that come from different vendors. Today, we are very much bounded to one vendor, one solution that goes all the way. And now you have a lot of interoperability between different components. This is the main thing that digital transformation brings.
Yep.
And this is a different skill. This is a different ecosystem. This is different capabilities that people need to have in order to be able to move forward. So someone needs to do those integrations, probably the operators, probably the solution providers, and this is where the challenge will be, and this is the advantage as well that comes. And Diffie is part of that, Wave is part of that, and there is more 5G part of that, creating all those kind of...
But just stepping back, one part of the question was, how complete do you believe the solution is as it stands at the moment? From a competitive landscape perspective.
It's working there. In order to get the solution will be complete, will there be a full interoperability. You can take a Kratos digitizer with an ESA antenna from them and from a modem from us and connect that to a OSS BSS. So this will be the complete solution. We are not there yet. We are working towards that. A little bit slow, some will say. But this is the end game. The end game is that you will be able to combine all of that together.
Yeah, and also interoperability with terrestrial networks.
Yeah.
That's the final piece.
That's an interesting one as well, because having looked at sort of in the past where 3G said there was going to be interoperability with satellite, and I'm showing my age here, 4G saying the same, it looks as though we might actually be finally getting there with 5G.
Probably on 6, but yeah.
Stuart.
Yeah, so I agree with everything that was said, particularly what Gil was saying. If you think about a digital ground system, what you do is you digitize the signal as close to the antenna as possible, and then you do your processing and software. Well, the way you transport that signal now is what's called digital IF, and so the Diffie organization basically exists to create an interoperable standard there. And we can see in that organization, at our last Plug Fest, we had 8 different companies who could all interop with their different products at the digital IF level. We just announced on Monday that 2 companies have now been certified, their products for certification to the Diffie standard, and we have 6 more companies in the queue going through the certification process, to go through the certification process now. So an ecosystem is absolutely being created for digital IF products that will be fully interoperable. And so I think that's, one piece of it, as Gil said. And then I think the other piece is, the integration at other levels, and, whether that be 5G NTN, whether that be supporting MEF standards, to integrate with the terrestrial operators.
3GPP, yeah.
3GPP. Those standards all exist on the terrestrial side. It's more about the satellite industry adopting those standards in a way that works for our industry.
So what standards do you think out of the, if you look at across the whole infrastructure, which areas do you see are lacking in standardization that perhaps more work needs to be done? Because we've got Diffie, we've got Wave working on specifying some of the environment, some of the hardware that some of the processing takes place. We've got work going on with ESAs through Diffie. What standards are missing at the moment? What standards do we need to see emerging in the industry for that complete picture to happen?
We're speaking about Diffie, we are speaking about 3GPP. I think we have to speak also about MEF. We have to speak about the board is missing, but okay. TM Forum, yeah. Yes, TM Forum also. Yeah, all those standards are very, very important. And as far all the industry are adopting the same standard, of course we will be interoperable, and this is the final goal. But I think that, in my opinion, something is still missing at the antenna level, because this is also very important, but I think this is my colleague that will explain what is missing at their level.
Yeah. So there's definitely some missing part out there. Let me give some example. For example, in 5G, right? 5G people are talking about a millimeter wave, so they're associated to beamforming, that kind of stuff, beam management, those are super complex algorithm and protocol. And until so far, beam tracking or beamforming technology in 5G world is still not quite there. However, in satcom, I think beamforming is essential, right? Even for multi-orbit. So there's no standard say, hey, when and how we should change from here to there. What's the constraint of the timing? How fast it will be? What's the power level and that kind of thing? We still need some time to figure it out. So far, for my company, we are trying as flexible as we can, because we work with partners to figure out that. We're trying to figure out that puzzle. So there's something still we don't know yet.
So just diving down a little into that particular area, you've got a whole load of people around this exhibit hall who are competitors. In what way do you think that the antenna industry needs to work together for providing an interoperable interface?
I think it's not about antenna company work together. It's about an antenna and a modem company work together. It's more like an integration issue. So from antenna point of view, yes, we are capable of doing beam steering, beam forming, beam tracking, anything that we can do. However, the algorithm was decided or determined by modem side, either modem or network. So for that part, we are still working with the partners to explore what's the right architecture to do that. But we are ready to offer the capability of the antenna. That means all the system, if you want, you can control through our API. Then the beam will form to here, there for you.
I think to refer to that, I think we have a lot of building blocks. I refer to the standards as the different building blocks. And what we are missing in continuity, what is who is going to take all those building blocks and build the building out of it? Make everything work together, connect everything together. So we have DIC and we have Wave and we have 5G NTN and 3GPP and MEF and all those stuff. But at the end, we need to take all of that into a solution, a system. And this is where we are now, I think, still missing, because the standards are still evolving, are still under process of being made. And then we will need to take all of that and build a system out of it to see how Diffie and Wave and 3GPP are connecting together to create a solution. This is the next step. So I don't think there is a missing standard. Maybe there is here and there, but at the end, we are missing the big picture of how to take all of that into a one solution, how to make it work.
Stuart?
Yeah, so I again agree with most of what was said here. I would say that it's not that we need more standards. We need to mature some of our standards. There is work being, like on flat panel antennas, they're being worked, or ESA antennas are work being done both at Diffie and GSOA about how to do the flat panel antenna, do the interfacing, how to certify them so that they're not certified like a parabolic where they're unduly punished because their advantages and capability aren't taken advantage of. So I think there just needs to be maturing of the standards. The 5G NTN release 17 was a great start, but there's still so much more to evolve, and you see it in release 18 and 19 drafts, but they just need to be matured. So I think we have the standards we need, we just need to mature them and implement them.
Yeah, I will join Diffie this year.
Okay, excellent. You'll be very, very welcome. Every input is great.
Yeah,
we do, but that's exactly what we need within these standards organizations, is everyone coming together to cooperate. And that was one of the things I really noticed about Diffie with some of the, at the Plugfest. A bunch of competitors suddenly coming to interact, to work together ahead of putting equipment out to the general industry so that we solve the problems ourselves before we let you those problems reach you. So, thinking about the infrastructure, we at ETL, we're still selling a lot of analog infrastructure. How do we? What's our thoughts on, with all that capex going into the analog? What's our thoughts on the need for hybridization, for how that will push across, how we will move all of the digitization? How will these things sit alongside each other and coexist as we move forwards? And Gil, I'll start with that one with you, if I may, please.
Thank you. So it's an evolution step. We are starting from a point that there is a lot of investment out there already, a lot of infrastructure that was deployed over the years and still being deployed, which is analog. And of course, if you jump 10 years ahead, everything will be digital. But this is the gap that we need to fill. It's an evolution. For some time, it will be two technologies sitting side by side. The solution that we will need to bring all of us, we need to be able to work in analog environment, a digital environment, and to allow the operators, the service provider, a slowly migration from one technology to the other. It's a gap that we will need to close, and I think part of the solutions that we are already seeing out there is to maintain that. Companies are bringing a virtual modem or a software-defined radio modem that has both RF analog interfaces and a Diffie port, SFP port that can do 10 gig or 100 gig in order to be able to be digitized at the end. So those kind of solutions that merge two technologies, the old one and the new one, this is what we are seeing, and we will see more of that in the gap until all the equipment will be merged into a new technology. But this is something that takes about 5 to 10 years. It's not something that happens tomorrow.
It certainly seems as though it's taking longer, perhaps, than maybe we might have expected maybe 5 years ago.
We need to remember that we are in the satellite industry. Traditionally, we are a very conservative satellite industry, moves a little bit slow, but there are changes, and there are places where we see that there is a faster movement, and there are places that we need to catch up with that. Yeah.
Michael.
Yeah, as I said already, for us at our OSS BSS level, we don't care if the hub is physical or if the hub is virtualized. For us, it's exactly the same. It's the API that is the interface that is the most important point for us. And for the rest, and then we can see a graceful evolution from physical infrastructure to virtual infrastructure. This is something we see, and typically teleport, they operate then physical hubs, and in the future they will move progressively to virtual hubs. But for us, okay, the API will be probably different. We will have more possibility to manage and to orchestrate the hub, and this is good, in terms of flexibility, and we can access probably other kind of waveform, etc., etc. And this is, I think, the goal, of course, of those kind of virtualization. But for us, we are already in the cloud. We are already fully digitalized, and then for us, we are already providing our solution purely OpEx-based. Of course, in some time they need to have a private POP for governmental needs, but this is something a little bit different. But for the rest, we are already in OpEx because we are in the cloud, and then it makes sense to have an OpEx model, and then the CapEx will probably reduce progressively as the virtualization is increasing.
Ethan, perhaps, because you're very much, with flat panels, you're going to be very much in the hardware domain.
Yes.
Still, because of course we're never going to get digits into the sky without some hardware in the loop.
Still, someone needs to, handle Maxwell equation physics. Antenna definitely is one of the part. We need to transmit energy, right, and the power. So that's how the signal can get it to LEO satellite and GEO satellite. So for some parts, there's no way to digitize that part. But what we do is we make the system or ESA system, we make it a software configurable. So that means whenever it's the same hardware piece, through software API, we can reconfigure the antenna to meet different missions, to meet different orbit. Of course, with the different swap. That means, especially in terms of power consumption. So for those, there's something we are bridging in between analog world and digital world. So for my opinion is that, yep, we are working that pretty hard. So that's why we need to work with other system block, modern network. We need to learn.
So do you see from your antennas that you'll be billing by the bit at the antenna level?
In antenna level?
You know, a truly OpEx antenna model.
Not built by Autumn, by 1 and 0, no. So I think so far the progress is we make it software defined and configurable. That's where we are so far. So for next level, that's a good question. Let me bring that back.
Okay, Stuart, in the meantime, yeah.
I think the driving factors in the industry that will drive us to digital ground, one I mentioned before was the next generations of satellites, the very HTS satellites and software-defined satellites. I think the other one that will be a driving factor is 5G. If you look at 5G, it assumes a virtualized infrastructure. And so if you want to get the true value out of 5G, you're going to move to you have to move to a digital ground. And I think, as I said before, the next generation satellites is where you'll see the 5G really implemented, I think, in earnest. I think you might see test networks on the existing satellites and legacy ones to learn about it before they launch their next generation, satellites, because this next generation of satellites are going to have, the small ones have 50 gig of capacity and the large ones have, anywhere from 120 to a terabyte of gig to 100 to a terabyte of capacity. That's a massive amount of capacity that the only way you are going to be able to support and deploy that cost effectively is in software. Because if you got to ship hardware everywhere, that's just not going to be cost effective. And so it's going to force you to move to a digital ground infrastructure and virtualization just because of the cost points. Because I think you said it, scale is what the industry's got to scale, and software allows you to scale way better than hardware.
Thank you. So just looking at the biggest roadblock that each of you see to digitalization at the moment, what do you think is really getting in the way of progress? Michael.
I think that the next step now is the adoption of virtualized hub. I think this is the next step, and it will go progressively. It will be not from one day to another.
But what do you think is the actual roadblock? What is stopping digitalization rolling out more?
What is stopping?
Yeah.
I think for the time being is probably still the cost because it's still, I think, I'm not a totally specialist, but what I see that in fact, as far as the current infrastructure is still working and is still doing the job, they will not change. But of course, with the new requirements that are coming, and we were speaking about governmental markets, then probably they will need to move in that direction. But it will not be from one day to another. It will be done progressively, and and I think it will not be very, very difficult. This will be done progressively, and as far as the cost is reducing, especially the cost of processing is reducing, then at a certain time it will be much more efficient and much less costly, and then of course the adoption will go much faster.
Thank you. Gil, your one key roadblock.
I think the rate that the standards are being finalized, it's too slow. And whatever standard you want to take. So some may be moving a little bit faster, but a lot of them are moving too slow, getting to the point that everyone agrees this is how it needs to be, this is how it needs to act. So we can go and implement that, the different companies, the different operator. I think this is the main roadblock because you see in different standards that they are missing some of the point because there are debates, so let's delay that to another release. And it's not close all the details. And if that moves too slow, getting into the digital era will take more time because we need these standards in order to create the interoperability, in order to move forward with different models, business models. And
so rate of progression of standards. Ethan, your key.
Yeah, I think it's about cost and technology. Okay, so we are the last piece. We are the slowest pace in terms of digitalization, right? We are antenna. So the cost of antenna, for example, where we start to analog and digital conversion, we need an ADC. So that's the component, the extra cost. Right? For one channel, we may need one. Well, for multiple channel, we need a multiple ADC for just one antenna. So those extra costs was affordable for the industry. So that's one showstopper. Another is about a technology, for example. Now, of course, we can do analog beamforming that works efficient and quite good now. But now, if we want to offer better services, we may need to hybrid, right? We use analog and digital beamforming together. We do hybrid beamforming. So now the technology itself, the maturity of the technology itself become the showstopper. Right? So we need different algorithm, how we can hybrid and create some also cost-effective solutions.
Stuart, a roadblock?
I'd say it's the delay in the VHTS and SDS satellites because I think that would, if the sooner they get launched, the sooner they're going to be a forcing factor to solve the standards problem. And they're going to have the scale that's going to allow us to start to address the cost problem. Because the cost problem is not going to get solved without scale. If you look at what Starlink did, they ordered 1 million user terminals before they even launched their first satellite. So all of a sudden they had scale day one in their satellite, in their antenna manufacturing. And that's why they could come out at the price points they came out at. The satellite industry traditionally doesn't operate that way. So until you're building satellites that have massive capacity, you're not going to order in the volumes that are going to need to allow these people to drive down their costs to allow you to be competitive. So I think it's the holding back of these software-defined satellites that have the scale that allow you to get to the cost points you need to compete.
And I think echoing that, it's very easy for 5G and for terrestrial to reach certain cost points because the market is so large for terminals. And in all my time in the satellite industry, we've always piggybacked off what the terrestrial guys have done just to be able to try and get to those cost points. But we're not seeing that in those processing elements and in those conversion elements that I see as some of the biggest cost points. And also the ability of general network infrastructure to support the data rates needed. So,
but that's why you're going to see the satellite industry has to move to 5G to be able to plug into that ecosystem and start using their chipsets that cost pennies versus hundreds of dollars for the custom-built satellite industry chipsets. So you get 2 orders of magnitude of savings if you plug into the 5G ecosystem, and that's what you're going to see happen, and just because you have to.
Perfect. Does anyone else want to come in any further on those questions before I open it up to the audience? So look, we have 10 minutes left in the session. We've got a microphone here in the middle of the floor here. I'd like, please, ladies and gentlemen, to open the questions up to yourselves.
Okay, we're hearing a lot about this, obviously, from the ground segment side. But to your point, Stuart, you're saying that with all these new software-defined and HTS satellites being launched, we are going to need a digital ground segment for them to get the full use out of these satellites. I'm curious as to why the onus seems to be on the ground segment. Are the satellite operators investing? Are they pushing? What are the satellite operators themselves doing to invest in the ground segment that you all say that they need to be competitive in this new environment?
So I'll start off with that. So if you look at the GEO operators, they have ordered the software-defined satellites. The problem is they were way harder to manufacture than people thought. And, I won't name names, but, if you read the news, which companies manufacture them, which ones are having the challenges. They've been delayed by 2 to 3 to 4 years, depending on the satellite. And so they've made the investment in the satellite side, but you don't need to buy the ground system until your satellite's going to get launched. So they've held off buying the infrastructure they need on the ground, because if the satellite's delayed 4 years, there's no reason to go buy a whole bunch of Gilat modems now. So they're going to wait, 2 years or 3 years, and then say, well, what's the industry status then? So the delay in satellites have delayed a lot of the adoption of the new technologies in the ground, I should say the deployment of the new technologies that's available in the ground systems.
Who else would like to come in on that?
I will add to that on top of that, they are not moving into cloud because, like you said, they don't have the satellite, they don't invest in the infrastructure, so that we don't see a big movement towards cloud. Private cloud, public cloud is the same thing in that sense, but they are delaying that as well. Let's see the satellite coming out of the manufacturer facility, and then we'll think about cloud infrastructure and everything that goes with that. So yeah, there is a delay in that as well.
Any other takes on that? Thank you, by the way, for an excellent question. Do we have any more questions, please, from the audience? No one else going to... We've covered everything. Then, just very quickly, I'll say, what's your next view of the next 10 years towards digitalization? And we'll just go from Stuart on through to Ethan.
So 10 years from now, no one will ever buy an analog ground system again by then, because no industry has ever moved digital and said, oops, this was a mistake, and went back to analog. And I don't think the satellite industry will do it either. So I think once you start making the transition, they'll just continue to occur.
Thank you.
Yeah, but for me, I think that in the future, I see that the satellite industry, the satellite operator, can break the silos and cooperate much more together. And thanks to the digital technology and digitalization, it's now totally feasible. And this is already what we do with our platform. We are interconnecting hubs worldwide and offer the possibility for satellite operator to cooperate and to sell and cross-sell capacities together, and totally transparently. And this is, I think, something that will certainly grow in the coming years.
There's a very, very interesting thought there on the cooperation needed.
Yeah.
I think from Gilat's side, looking ahead, is the transformation from being a hardware-based company to a software-based company. There is a lot around that. It's business model, it's capabilities of people, the type of people that you work, the type of integrations that you are doing. It creates a lot of changes. So moving from a hardware-based company to a software, and we will see a lot of companies doing exactly this shift. It's not an easy shift to move from hardware to software. So this is the main thing.
Finally, Ethan.
Yeah, in next 10 years, what I can picture is heterogeneous network. They all work perfectly seamless together. 5G, and by then, 6G. Mm-hmm. Satellite, LEO, GEO, MEO, everything in one big network. That's my first imagine to the future. Second, my ESA will be everywhere. Thank you.
Fantastic. Look, ladies and gentlemen, would you please put your hands together and thank our panel, please.
Thank you, Simon.
And thank you everyone for your attention, and if no more questions, I'll bring the session to a close. Thank you.